This video is about API designs to support consistent error handling, specifically within Flask. So the main goal that we're trying to achieve here is that whenever there's an error in our application can seamlessly handle that error and deliver consistent responses to our users and ensure that our servers don't go down because of unexpected errors. So the main thing that we start with is having some kind of structure to all of our responses. So that's kind of the main purpose of this directory here that I called responses, where I initialize this class called response, and where all it's doing is generating a Flask response that it's gonna encode in JSON some data, and then a given status code. So at this point, this could be something completely modifiable. We can give a consistent response or structure to all of our responses, being those the ones that error out or those that just contain normal responses. And the main goal is that from this response, we can do something special when we encounter errors. So I created an errors directory in where I defined an error class. Here I called it base custom error. In this case, contains a status code, a default error message whenever an error is presented, and the user, or in this case the developer, does not specify any other message given the context. So this is kind of like that default message. And then we have two other fields, which I called public and debug. Public is basically any information that we wish to present or send back to the user. And debug is anything that's internal, perhaps something more sensitive. And it's something that we would only keep within our server, and we would only log within our server and never send back to the user. So as I mentioned, we're just initializing a class with these two properties, the public and the debug. And then we're instantiating this logger method where if we don't have anything to debug, we don't do anything. And in case we do have something to debug, we're going to grab the logger out of the current application. This current app is imported from Flask, is the current running app. And then we're just going to access the logger, and then we're just going to debug some information. So that's kind of our starting point. And then we can inherit from this class to create custom errors. So in this case, we have a forbidden error where I specify a status code and then a default public message. And then I do the same for different kind of requests. So I have a bad request error right here, server error, and unauthorized error. So those are the main errors. And the way we would use them is on our Flask endpoints, we can just issue them. So at any given point, we can raise that error, raise server error. In this case, if you remember, there's a public and debug. So this first argument is just a dictionary. In this case, I'm just filling it with nonsense, but this could be any kind of information that the user is going to be sent back. And then the debug is just some internal state that we're just going to log. So in this case, if I run my Flask application and then I'm issuing some kind of request to this endpoint is being served under API/users. So if I hit this endpoint, in this case, I get an error. You can see that I get this data back, so the AN1, and then you can see that internally I'm seeing the error under debug, and I'm seeing that metadata. In this case, user ID is 123. But you can imagine that this could be very powerful as our applications grows in complexity to being able to track down and debug any kind of complex issues that may arise. So in the other case, if I run this enough, I'll get a response that doesn't error out. So in this case, I just get a normal response like so with a 200 status code. And that's kind of the gist of it. The only thing necessary to make this work is on our application definition. We set up a error handler, so we're catching for all exceptions, and then we're delegating that handling to an error handler, which I'm storing here under middlewares. And this function, all it's doing, it's pretty simple. It's just basically checking if the exception that was caught belongs to our custom error class. And if it is, it's going to expect some properties to be there. So in this case, the status code and the error. In here, we're also doing some logging, and then finally, I'm just returning a response. And this final return would be for a generic error, hence why I'm logging here the traceback. So I want the full stack because this is something that my code is not handling, and I would like to have as much information as possible. So in this case, just getting the status code, and then finally just issuing uh, a generic default public message. So for a server error. So in this case, I could just say that this is an uncaught error. So I could actually hard code here, let's say 500, or if I want to be consistent, I could use server error and then the status code right here, which is going to be of 500. And then the final point that I think is also a good idea is to have a fallback route. This is essentially a catch-all route. So in any case that a user provides a route that does not match against anything, you redirect it to an endpoint that you define. In this case, I called it catch-all. And this endpoint, all it's doing is issuing a new request saying that this is an invalid path. And I could just call that by issuing a request to something that I do not have defined. So hello, and then I'll get an invalid path. And you can see that I'm getting the benefits of being able to consistently handle my errors and also being able to consistently define the format of all of my responses.